The next learning objective when dealing with forces is I can sum two or more one-dimensional force vectors to find a resultant net force. One keyword here is net force. We need to understand what that means. So the definition of net force is the sum of all forces. So sum is just math word meaning add up. The idea is that we're just going to add up all the forces, and that's going to be the net force. This little notation right here is called sigma, capital sigma, and it represents sum of. So in other words, add up all of the. And then the next part on this expression is a capital F with a little subscript of x. The idea behind that is that we're going to add up all the forces specifically just in the x direction. We talked in a previous video about the idea that motion in two perpendicular directions are independent of each other. It doesn't matter how fast you're going in the x direction or how fast you're going in the y. The same idea can be applied with forces. Forces in the x direction do not impact forces in the y direction. We're going to take this one force, one direction, I should say, at a time. And for most of the time, it's just going to be in the x direction. This expression right here just means net force in the x direction, or add up all the forces in the x direction. Take a look at this graphic. This is representing two opposing parties on a tug-of-war game. And the idea is that they're pulling with both sides. They're pulling certain amounts, depending on how many there are, how big a person they are. On the left side, we have a left force, so a force going to the left, of 250 newtons. On the right side, we have a force of 300 newtons. They have more people on the right side, so it makes sense that they're pulling harder. If you add up all the forces, you get 50 newtons. Now you might be thinking, wait, shouldn't we get 550 newtons? The idea behind this is that we need to assign a direction. So for this case, we're going to say that to the right is positive and to the left is negative. So that actually means that this is a negative 250 newtons. So if you add a negative 250 newtons to 300 newtons, you get positive 50 newtons left. That's the idea of summing up all the forces or finding net force. Assign negative forces to the negative direction and positive newtons to the positive direction, and then add them up. This will allow us to get, if it's perfectly balanced, a net force of 0. There's an equal pull in both directions. Using the simulator, we can play around with this idea. So let's say we have one big person versus one small person. You can notice on the right side we have 150 newtons, and on the left side 50 newtons. The sum of forces is 100 newtons. We could try to balance this out. So here we have two people on both sides, one small, one large, and both sides are pulling with 200 newtons. This makes the sum of all forces 0. So what would happen if we let this simulation play out? Well, they're going to pull against each other, and the cart is going to go nowhere. Now, if we just add one more person, such that we get that 50 Newton difference, what would happen now if we let the simulation run and see where the cart goes? As you can see, the cart starts going to the right, slow at first, but then it starts picking up speed because it's accelerating. Let's try out this learning objective with an example. Let's say we have a box, and this box is being subjected to 3 forces. 2 are going to the right, and 1 is going to the left. Force 1 is 100 newtons, and it's going towards the right. Force 2 is 75 newtons, and it's going to the right. And force 3 is 125 newtons, going to the left. Now we can label these out. This is the 100 Newton force. This is the 75 Newton force. And this one, force 3, we're not going to write 125. We're going to write negative 125. Because what we need to do is assign a direction. And typically, to the right is going to be positive, and to the left is going to be negative. Now, let's start with the sum of all forces in the x direction equal, and let's just go from 1 all the way to 3. So force 1 plus force 2 plus force 3. There is another way you could represent force 3, and that's instead of adding the negative sign right here and writing plus force 3, what you could do is you could put minus, because we know it's going to be the negative direction, the absolute value of force 3, and we can get rid of the negative sign there. The idea is that we are already assigning the direction by putting the negative there. So that's where our negative comes in, is not in the number itself, but instead whether we're adding it or subtracting it. By subtracting it, we're indicating that that force was in the negative direction. However, for now, we'll keep it with plus F3 and having the number there being negative. Let's write this out. We got 100 newtons plus 75 newtons minus 125 newtons. 100 plus 75 is 175 newtons minus 125 newtons is going to get you a positive 50 newtons. So the sum of all forces, also called the net force, in the x direction is 50 newtons. There are two practice problems. The first one is a force of 35 newtons acts forward and a 25 newton force acts backwards. What is the net force? Now you could probably do this in your head, but I'd recommend for the practice sake, write this out. If 52 newton force is pulling down on an object and a second force is pulling up, if the net force has a magnitude of 14 newtons and points downwards, what is the magnitude of the upward force? This one's a little bit different than the example problem I gave before. If we go back to the example problem, the idea is that we had all three forces and we were solving for the net force. But here we have the net force and we have one of the forces, and what we're doing is solving for the other force. When it says downwards and upwards, it's going to be up to you to define whether down is positive or down is negative. As long as you're consistent, physics will work out either way.